Welcome to this special episode of AU Manufacturing Conversations, which is part of our annual Australia's 50 Most Innovative Manufacturers campaign. This time around, the 50 Most Innovative has been made possible through the support of these wonderful sponsors: Australia Wide Engineering Recruitment, TXM Lean Solutions, the Industry Capability Network, Bonfiglioli Australia, the Advanced Manufacturing Growth Centre, and the SmartCrete CRC. Now on with the show.
David, thank you for joining us today. Before we dive into the fascinating world of tailings management, could you introduce yourself and tell our listeners a bit about your role at Phibion?
Okay. Well, first of all, thank you very much for having me along today. You're getting me to speak about my favourite subject, and Phibion is something of my baby. To sort of give you a little bit of background, currently I'm a non-executive director with Phibion, and I guess I'll come to what I do with that a little bit later. But to give you some background on me, and I didn't land in this space by a direct route. So my background, unusually for tailings management, I'm a scientist. I have degrees in atmospheric physics, computer science, environmental science, and business management from Murdoch University and Deakin University. And prior to starting Phibion, all the way back in 2006, I spent the best part of 20 years working in the mining industry in various roles with such esteemed companies as Alcoa, Alias Lonza, Alcan, and Rio Tinto. Winding that forward to today as a director of Phibion now, so initially a founder and now a director, my role is really to mentor our leadership team and to provide strategic advice on the company, how it's going and where it can go in the future.
Brilliant, thank you. And for the listeners who might not be familiar with the mining industry, could you give us a brief overview of Phibion and its commitment to innovation in tailings management, please?
So Phibion is a little bit different. We're an advanced tailings management company. We develop proprietary tailings management technology and tailings management equipment. So what does that mean? So the company deploys what's a tailings management process, which we term accelerated mechanical consolidation. Now, it's a little bit of a mouthful. So we refer to it as AMC. So if you hear me talking about AMC, that's what I mean. And working with that technology, we have some rather unusual equipment that we developed, and they're what's known as a twin Archimedes screw tractor. And again, that's also a mouthful. So our term for that particular vehicle is the Mudmaster. And the overall mission of Phibion as a company is to make tailings operations safer, smaller, and more sustainable for our customers. So we deploy both of these technologies as a service, rather unusually. We're not in the business of really selling them, but we deploy it as a service. And we do so that our customers, primarily our mining customers, are not faced with any additional capital expenditure associated with trying to improve their tailings solution. And in most cases, we can drop onto a customer site and we actually ask them not to change a thing. So as you could probably, I guess, understand, wandering onto a customer site and asking them not to change a thing actually places an enormous amount of responsibility on us. And so to manage that rather onerous requirement, we do enormous amounts of R&D, and we have to provide the innovation to try and solve a customer's issues. And this has been rather rewarding because it's given us a really deep skill set to manage almost any issue that you could possibly imagine in the tailings environment. And of course, it also gives us, because we've got such a wide brief or wide view of the tailings world, it drives us to innovate, and more importantly, drives us to develop solutions to issues that maybe no one else can see or don't exist yet or are emerging. So that really does keep us on the cutting edge of what we need to do.
Amazing. You already answered my next question, which was what led to the founding of Phibion and what specific problem in the industry were you trying to solve? Is there anything that you want to add to answer that one, or should we move on to the next one?
Okay. So yes, I do. I can add a little bit more to that because the answer to this is not intuitive. So Phibion came out of a deep desire to solve a question that I was being asked in my previous roles in the industry. So in my previous roles, I was expected to be responsible for issues that I couldn't quantify. And by that, I mean a tailings dam is an unusual feature. In previous roles, or when you were responsible for tailings dams, you're often asked, tell me what the density of a tailings is out somewhere. Tell me what the strength is under a future construction zone. Now, what's interesting is you don't know. You can't measure it. You can't get access to it. And arguably, we probably know more about the surface of the moon than we know about some of the physical characteristics of tailings in the centre of some of our larger tailings dams across the world. So because you couldn't get to it safely, you couldn't measure it. And so therefore, it had to be estimated, which is a polite way of saying you professionally guessed it. And that introduces an enormous amount of uncertainty, not only in terms of is the information I'm providing either superiors or regulators or others correct, but it is my lack of certainty providing misinformation, which is something that just did not sit well with me. So what I wanted, or effectively why Phibion was founded, was I wanted to develop a tailings management process that delivered certainty, business certainty, rather than accept uncertainty. And from a business perspective, I kind of knew that there would be financial value in being able to close that gap. So that's really how this journey started.
And just for people who aren't as, I guess, into the industry as perhaps you are, could you explain a little bit about what tailings management is?
So we live in a modern world where we have all of the extraordinary toys and systems that enable us to live a very comfortable existence. So to make all of those things work, some rather unusual metals and materials have to go into their construction, and they have to come from somewhere. We can't fabricate them. We have to refine them. We have to mine them. We have to extract them. And invariably, these materials are not common. They're hard to find. And once you've found them, they're hard to extract. And so what does that mean from a mining perspective? It means you're chasing something which might be in the few percent concentration or a couple of grams per tonne or some tiny amount of concentration, of which you've got to apply some sort of extraordinarily expensive and probably innovative means of extracting it. But the flip side of that is no matter how rich your ore body is, whatever you extract, what is left over is invariably called tailings. So in my example of, say, a few percent, say a good example would be a copper operation. If you can find a copper ore body which is delivering a 2 or 3% grade, you are going to chase that and you are going to mine that. But what that means is that 98% of what you're chasing in mining is not going to be used. It's going to be a tailings. And when you look at the enormous quantities of materials we need to run our modern world, and then multiply that by the various 98% or similar around the place, there is a gargantuan amount of tailings being generated around the world. And all of that has been through some sort of process, which meant it consumed water, consumed energy. It needed to be ground to a fine level to extract whatever you were chasing. And maybe even you had to add some reagents to assist that process. So now you've got this vast stream of material, which is kind of unlike normal construction material or anything else. It's a slurry of various forms and density. But that has to be safely managed. It has to be safely contained so it doesn't represent a risk to your operation, the people within it, or your surrounding communities. But also it doesn't represent a risk either immediately or in the longer term to the surrounding environment. So just consuming these various articles that we do in our day-to-day life has an enormous knock-on effect, both across the world and through time.
That was a really, really good answer.
Oh, thank you for just throwing me a curveball.
Yeah, no worries. It's what I do best. Okay, so moving on to the Mudmaster story. Let's start with the origins of the Mudmaster and its development journey. What was the initial vision behind creating this technology?
Okay, so I'm going to take you on a very short journey right the way back to day one of my professional career as a vacation student with Alcoa in Western Australia. And effectively, this literally happened on day one, which is quite incredible when you start to look at the impact on a career and where things have gone. But what I saw at Alcoa is they were mining bauxite. They were extracting alumina and they were left with the tailings, which is actually called bauxite residue. And one of the issues that they had was that they were not able to place this bauxite residue and have it dewater, dry, to a form where they would remove most of the moisture and it became solid, safe, stable, easier to manage. And so part of their process was they were effectively trying to manage some of the symptoms of that process. And they had a small vehicle, and it's very similar to what you see we have in our fleet today, in that it was a twin Archimedes screw tractor. However, it was of a Dutch design, very, very light, and it was called an Amphiroll. And essentially that vessel was an acceptance that there were things that they couldn't solve. And here was a vehicle that could probably get human beings to places where they shouldn't be, and importantly, use it to break up a surface crust on the tailings, which would form under very, very strong solar drying, which is what you would get in Western Australia. And that process of forming a crust would effectively be self-sealing. So it would seal itself off from further moisture removal, and the whole process would stop. Now, at that particular time, I was doing an honours degree with Murdoch University, and I was looking at ways, because this was very important to the company, I was looking at ways to try and improve the tailings dewatering rate. And for reasons that I don't know, one of the operators of the day didn't like me, didn't take a particular shine to me, and drove through my research project. And I should say was smiling all the way as he watched my reaction from the shore.
Well, that's rude.
And it was a little rude, and I was very upset. However, it might have been the single most important thing that happened in my career, because he drove through all the instrumentation, completely smashed everything with what I was doing. It was ruined. And we're talking about an experiment that had gone for 6 months, 7 days a week, that sort of thing. So I thought, well, okay. So I collected everything, went back to my office and ignored it and moved on to other projects. However, I came to a point in time when I was going to clear the data logger and use it for other things. And I thought, oh, there's that data. I was about to delete it, and I thought, oh, no, I'll have a look at it. And I did, and the penny dropped that something was going on that I wasn't expecting, and to the best of my knowledge, no one else had seen before. And I didn't know what to do with that, so I just kind of shuffled that back into my mind and moved on with my career and did other things. But it actually became an itch that I eventually had to scratch more than anything else. That was, and we're talking, I'm giving my age away here, we're talking 1989 here. And that's a polite giggle. So come 2006, I developed or moved along in my career, and this had just become something that I couldn't ignore anymore. And I thought, right, I think I can do a better version of tailings management. It not only solves the problem, but it improves safety, it reduces environmental impact, and in doing so, it will create sustaining value for the local community. So that's kind of where it all started.
And did you have a particular light bulb moment looking back?
As in creating the company, or
Well,
from when that...
I guess any light bulb moment, really.
Okay. And this is back in the days of incandescent too. So it was sitting alone in my office in probably about 1990 when I'm about to clear this. And I thought, nothing has happened since I stopped researching. I'd actually finished my thesis and submitted that and moved on. And I realized from all of my literature review, no one else was looking at it either. So I just thought, I wonder, is there a way to use or design a piece of equipment which will actually do what that machine did, only better? Can I make it reliable? Can I make it safer? And can I actually create an improved solution? And that'll happen within, a couple of minutes of looking at the data set and quietly sipping on my coffee. That, if there was a light bulb moment, that was it. And it just, to be honest, it just annoyed me and kept annoying me for 10 years.
Well, I'm glad to hear that your thesis was the basis of something, because I'm currently working my way through a thesis and I can't wait to be rid of it. But I hope that one day I look back at it also and actually use my literature review for something productive.
It's life has a habit of turning you in unexpected ways. Mind you, I actually pulled my thesis today when I was just looking for bits and pieces for this conversation. And it is an invigorating document which has the attention-grabbing headline of a study of the dewatering of bauxite residue. Now, if there is anything which you need to put you to sleep when you've had one too many coffees, there's the book for you.
Oh, could you send it to me? I'd love some assistance in getting to sleep before 9. That would be great.
It is not the most riveting thing, but it wasn't riveting for all of the reasons that the technology wasn't working previously.
Mm-hmm.
It's only when you kind of clear all of that away that you realise, well, hang on, there is actually some good in this, and if you connect the dots the right way, there is opportunity, and that's kind of where it came from.
This is a short interlude to again thank the sponsors that are making 2025's 50 Most Innovative campaign possible. Our appreciation goes out to these legends: Australia Wide Engineering Recruitment, TXM Lean Solutions, the Industry Capability Network, Bonfiglioli Australia, the Advanced Manufacturing Growth Centre, and the SmartCrete CRC. Now back to the show.
Okay, so moving on to the next question that I have down here. Why is tailings management so critical for the mining industry? Many of our listeners might not be familiar with the challenges involved. I know you touched on it a bit earlier, but it might be good to just, go over it again.
So moving on, I guess, from what I mentioned earlier, tailings is, if you like, the modern world has us consuming various bits and pieces, but it is really tip of the iceberg stuff in terms of what else is going on in the background. So when you're talking about such large volumes of tailings, and I'm talking billions of tonnes here across the world on an annual basis, you need very, very large facilities to manage all of this. And you only need a very quick trip through Google Earth and looking at various mining areas around the world to realise these facilities are immense, and they have to be immense to deal with the volumes of material that are required. But of course, to create such large facilities, these need to be engineered right. And there is an enormous industry associated with making these facilities, designing them appropriately, operating them appropriately, and making sure that the tailings that are contained within them pose a minimal risk to people and planet. And we're talking facilities which you measure in the tens of square kilometres in some cases. They are absolutely huge. Now, although you can employ the best engineers and the best construction, etc., sometimes things go wrong. And unfortunately, in recent history, we've seen a number of these facilities collapse or overtop or otherwise fail around the world. And in doing so, there's actually been a significant loss of life associated with this. And notwithstanding that, also significant environmental impact on downstream communities and also locally within the communities themselves, either direct damage or just the economic damage associated with no longer being able to function as a community or work within the existing operation. So if you were to look at any risk register of any significant mining company in the world, literally guaranteed in the top 3 somewhere will be ongoing management or processes that they need to mitigate the risks of this facility failing and causing catastrophic damage. And so that has created enormous industry pressure, not only, community and society pressure, but industry pressure to seek out suitable technologies that can either mitigate or minimise this risk wherever it is possible, wherever it is needed.
Okay, and on that note, what particular vision did you have when creating a high-performance, reliable machine for this specific purpose?
So it's a tricky question, and sort of it's like saying all tailings are different, and they are hugely different. So there is as different as commodities that generate them as well. And so coming up with one single fixed solution is just not possible. So to get around that, both the management philosophy that we apply to this AMC and the machine itself had to be adaptable to try and create a bespoke solution for any suitable tailings. So the process, I guess, around that, or the vision that sits around that, is that what we're trying to do is we're letting the properties of the tailings, the individual tailings, define the solution that is required. So the property of any customer's tailings, we use our AMC modeling capability to define the solution that will best manage those particular tailings. Now, once we have those properties and we have that solution, an outcome of that is it then defines the operating parameters or the specification associated with the Mudmaster. And so that kind of simplifies a lot of what we're doing. And although it may look like we have one machine that can deal with everything, what we have is one machine that is infinitely customizable, if that is a word, to be able to accept all these different technologies. And so on the machine itself, what we've done is we've kind of tried to fix everything that occurs above the waterline. So we standardize everything as best we can. However, what goes on below the waterline, effectively where our ground engagement or what we call our scrolls operate, that design we can change. And to get into the tailings, the geeky tailings end of this, what this effectively allows us to do is change the density of the machine relative to the density of the tailings. And so we have a range of fixed scroll designs with overlapping design envelopes. And so what that means is that based on the outcome or the output of the AMC model, we can now select a scroll design, which if we put that on that machine, it will operate a certain way to meet that customer's requirements. Interestingly, if we were to remove that machine and we had to use that machine in a different location, different commodity, or with a different customer, we could then reassess the AMC requirements for that new customer site. That will then generate a scroll design. We would then be able to fit a new scroll design and the machine would behave quite differently, but absolutely perfect for that new customer application. And so that's allowed us to have somewhat of a fixed fleet, but a little bit of if you like, a Swiss Army knife approach to what we're doing. We've standardized it, but we've standardized it to a range of options, which then allows us to address any need.
Why was it important for Phibion to manufacture the Mudmaster in Australia to the highest manufacturing standards?
Since we started the company, it became very much apparent early on that, if you like, the secret to our success was going to be we had to innovate, we had to simplify, and we had to standardize in pretty much everything we did. So this approach improves the solution that we can deliver. It improves the robustness of our supply chains, and it reduces the costs, which we can then pass on to our customers. So taking that as a bit of a mantra, why manufacture in Australia? Or if you like, the reverse of that question is, which is something that I was asked all the time, and that is, why don't you build this machine in China? It would cost you less. And absolutely right, absolutely correct. But importantly, that's not the point. We're not in the business of selling a product. We're in the business of selling a solution. And when you look at it like that, we were developing something new, something different, something unexpected, and very early on realized that we couldn't do this on our own. And we had to develop something of an ecosystem that sat around us to support not only the company, but also the technology, so that as we would grow and come across new challenges, we had some depth to our experience, not only in how we delivered the solution, but also in the robustness of the solution. And that just became so important as we were trying to grow the business across geographies, time zones, commodities, etc. And I guess the other part of that is we were working in probably the harshest environment possible. And when you do that, anything less than the very best that you can do, it's just not going to last. And given that we were providing the solution and we were owning, to some extent, the success of that solution or the effectiveness of that solution, if we didn't get it right, or we got let down by the quality of the equipment or the standards that were applied to it, it was going to cost us. not only financially, but probably more importantly, in reputation. So we're kind of driven towards manufacturing towards the best possible engineering standards. And I guess fortunately in Australia, that's what we have. We have excellent engineering standards. They are well documented, they're transparent, they're robust, and there is a deep pool of expertise that supports all of those. And I guess the other part of, if you like, manufacturing in Australia to make all of that work is that we could visit our fabricators. We could audit, we could test, we could see how we're going and talk and discuss and create that conversation around innovation. And that became, and still is, a major advantage to what we do. And I guess probably the hidden value in all of that is that this isn't a combative process. We're not chasing the cheapest possible solution in all cases. We're chasing the best. And that's what we've clearly discussed with our suppliers. They know why we're asking questions and they know why they're critical. And they know that if we get it wrong or they get it wrong, then everyone suffers. So we're kind of all in this together. And we just do not want to and cannot afford to get things wrong.
And on that note, the MudMaster V6 with Dart autonomous capability is described as the only machine of its kind globally. What makes it so unique?
Wandering out into the middle of a tailings facility in a twin Archimedes screw tractor is very interesting. But it's even more interesting when you look at it in terms of from a customer's perspective. So from a customer's perspective, they are told day in and day out that their tailings facility or their tailings management is one of their single largest risks to their operation, the surrounding environment, community, etc. So they don't want to go near it. They take all of that very, very seriously. So when you look at it in terms of how do we develop a business, which, well, that's what we do, the single biggest impediment to growing our business is actually convincing our customer that it's safe to send a human being out onto the tailings facility. So we spend a lot of time talking with our customers and making it very, very clear that what we want to do and how we want to operate the equipment is very, very safe and it can be done. But you can imagine that takes an enormous amount of time to do that. And while we're spending our time convincing customers of this, we're not spending our time actually delivering the solution. Following on from that, trying to find operators and train operators to a very, very high standard to be able to operate this equipment in the middle of a tailings facility is difficult. It's hard. When you find very, very good operators, you want to hang on to them, but the simple fact is there's not enough. They're very, very hard to get. And probably the third factor on this is humans being humans. There are process impacts associated with having to take breaks, meals, hygiene, fatigue, total work hours, all of that sort of stuff. And again, humans being humans, even with the best of training, they don't do everything the same. So there is some variability in operation that you just can't avoid. So if you look at all of sort of those three issues and pull all of that together, if we're looking at an autonomous system, we can actually solve a lot of those issues up front. And I guess the beauty of being able to do that is that we can take out the variability, we can improve the productivity, and because we're improving the quality of the solution, we can actually reduce the time it takes for us to deliver a high density or a high strength tailing solution to the customer. And I guess probably, if you like, sitting in parallel with all of that, because we've got more predictability and more control over how we deliver the solution, we can now deliver it very, very tightly to a pre-agreed plan, lock in the expectations both for ourselves and for our customer, and to deliver all of that on time, on budget, and to meet specification.
And I understand you're manufacturing in Brisbane with the capability to ship anywhere in the world within 60 to 90 days. How have you achieved that level of efficiency?
All right. Well, it all comes back to standardization and that mantra of simplify and standardize. So when you look at a MudMaster, it looks like a large and complicated machine, but in actual fact, we build it in modules. So we can build a cabin separately, we can build a power module separately, we can build a chassis separately, and all the various scrolls that we can put on that machine, we can build them separately. And so that allows us to hold some inventory of all these various modules. So once we resolve a customer requirements about the AMC solution that we're going to deliver, we're now selecting all of these various modules, and we can then assemble to meet exactly what the customer requires. And because we already have some of that in inventory, we can do that assembly very, very quickly. And because pretty much every time we ship a Mudmaster, we're on a ship, we have standardized our freight solution. So now it's something that we kind of do every week, where we deliver a machine, we have a standard freight solution, and we can integrate with the world's shipping system very, very quickly and very, very easily.
And could you please walk us through the key technical features that set the Mudmaster apart from other solutions?
So there are some, if you like, obvious design features, I guess, with the machine in terms of how we build it, how we design it, how we apply it as a standardized solution that we can then customize through assembly. But something we don't talk about too much, and this is really something that no one really knows much about, is that we actually continuously monitor all of these machines all over the world around the clock. So we know at all times what the machines are doing, where they are, how they're behaving, how they're operating, are they meeting performance requirements, etc. We have all of the machines linked in to the cloud as well. So we have not only real-time monitoring capabilities, but we also download from those machines all over the world. So when we access it, it doesn't matter whether we're operating in Brazil or Madagascar or Canada or whatever, those files are effectively available to anyone in Phibion, anywhere in the world, very simply. And because we have that access to the data, we can do a real-time interrogation of that. And if we need to change what we're doing, either we are troubleshooting an issue, assessing an operator, or if necessary, we need to change some operational parameters because there is some special condition or unusual situation that requires some additional help, we can actually change those operational parameters, upload it to the machine, and the machine will behave differently and have different capabilities, which is not something you hear about too often and gives us enormous scope to modify how we deliver the solution.
And how does your design ensure efficiency, reliability, and longevity in harsh mining environments?
There's no other way to say it. We have over 500,000 hours of experience operating in all types of tailings all over the world in different conditions, in different circumstances. No one else has that sort of experience. And this is the pain of experience. And I'll address it by saying we've now had the opportunity to battle harden everything we do on the machine. So every issue we've had, every failure or improvement opportunity we've identified over all of that period of time, we've now incorporated that into our design. We've learned from it, and we've now adopted that into our standard approach. So we have learned by doing. Some of it has been very clever. Some of it has been very expensive, but we've learned nonetheless.
Great. And what customization options do you offer clients with different needs?
We're offering effectively a bespoke solution. So for a given need, we're offering the best possible solution that meets the customer's requirement. However, now, because of the recent development on the autonomous capability, we're now able to offer, particularly those customers that already have an existing AMC operation, the full benefits of the automation. And what that does, of course, is, as I mentioned before, it gives us the opportunity to offer those improvements in productivity and performance, even if they've already got an excellent human operator solution.
Could you share some success stories from the field? How has the Mudmaster transformed tailings management for your clients?
So I guess in no particular order, there's a few. And I will name the operations because we have published this information and we also have very broad support for how successful things have been. So we have extensive operation at Worsley Alumina in Western Australia, and we've been there for a number of years. And their primary concern, and I should say they're in the business of extracting alumina from bauxite, and they are one of the largest operations in the world in terms of the throughput of tailings in this commodity. Their most significant issue is they had a large tailings facility, but the problem they had is the way they were placing their tailings it was taking them close on 2 years for them to have that material dewater to such a point where they reached their target density, which actually dictates the life of the facility, and also to achieve the necessary strength, which allowed them to increase the size or increase the capacity of the facility in line with production. And at 2 years, that meant their facility had to be so much larger than what it really needed to be. And so we were asked to assist, and we're actually able to reduce that 2-year period down to 6 weeks. And that's something like a 95% reduction in the time. And what that meant was that all of a sudden they didn't need as large area to sustain the operation. It also meant that we actually asked them to reduce the density of discharge into the tailings area, which allowed them to reduce their energy costs, gave them a faster rotation, a smaller operating facility to be able to run, and gave them a lower cost solution than any other comparable solution. They have been extraordinarily successful with this. We've been working with them for quite some time and hope to do so for much longer. I have another example, and this is where you move out of the world of direct tailings issues to one of social impact. So we were asked to assist an operation in southern Brazil, a zinc operation, Tres Marias. Their big problem, they had insufficient tailings capacity for their operation, and they didn't have enough time to solve that capacity issue, meaning they had plans to expand, but the approval times for those expansions were going to take longer than the available capacity. Essentially, it meant it threatened the viability of the operation, and we're talking thousands of jobs, and in a town with one large employer, that was going to have a huge social impact. So we were asked to assist, and so we implemented a solution. And in doing so, what the AMC solution did was increase the density of the tailings that had already been placed in the area. And so we were consolidating what was there, plus taking what was being produced. And we actually reduced the volume of tailings that were in storage and effectively made our own capacity. And what that allowed was that it basically gave a longer operating life to what was there, and in actual fact allowed them to keep going. And that's great, I guess, from a tailing solution, but look at it from a social impact. It then meant that we sustained the viability of that employer, and it saved thousands of jobs, which is quite remarkable when you look at it and you say, well, it was just a tailing solution, but it actually impacted on thousands of people, thousands of families, and the viability of that town. In a similar vein, we operate with the Jamalco alumina refinery in Jamaica, and they had a similar sort of issue. They were running out of capacity, but they had an additional complication, and that is their financial situation was such that they were not able to procure the capital necessary to expand, kind of almost on any timeline. So again, they approached us and asked if we could assist, which was an interesting experience because their industry experts that they brought in made it very public that our technology was not going to work, particularly in Jamaican bauxite residue, which within the industry is known and understood to be very, very difficult to deal with. However, we continued on, and in much the same way as the previous example, we were able to increase the density and build the additional capacity by consolidating what was there. But we also improved the safety of the operation, kept it going, and in fact, we've been able to improve it to such an extent that that operation is now going to be able to keep going for the foreseeable future. So again, Jamalco is a major employer in southern Jamaica, impact on thousands of jobs and families, etc. And we've been able to play our part closely with the customer to keep that operation going, and we would hope to continue well into the future. And probably my last example would be we worked very, very closely with Lynas Rare Earths in Western Australia, their Mount Weld operation. Now, they had the interesting position of they were building a rare earths plant. This is going back 10 years now. They were in a new operation. And so they were trying to not only invent their process, they were trying to manage all of the issues associated with tailings. And at the time, they took the best available information, best available technology on how that was going to go. And there were estimates and plans associated with that. However, like most things, not everything goes according to plan, and their tailings density, their final tailings density that they were achieving in their system was quite low. In fact, about half what they expected. And when that occurs, essentially that means they're going to consume the volume available far quicker than they thought they were. Now, of course, as a small company that was growing fast, investing heavily in a new process, they didn't have capital available to solve that problem, to build additional tailings storage capacity. They were spending everything they had on developing the plant. And so they approached us and asked whether we could assist. And it was very, very challenging. But what we were able to do is we were able to, again, as like the previous examples, increase the density of the existing tailings, the tailings that had already been placed, and effectively made our own capacity, not only to solve the initial problem, but also to sustain the operation. And that removed the capital threat to the company. And it also meant that they weren't going to be increasing their tailings footprint through additional expansion in line with their existing approvals. So we had the privilege of being able to solve one of their major problems and buy them time so that they could actually solve some of their process issues. And now they are extraordinarily successful and a growing and thriving company. And we continue to work with them and hope to do so for the foreseeable future.
What environmental and operational benefits have been observed through your accelerated mechanical consolidation approach with the Mudmaster?
I guess the biggest things that comes out of our process, so of AMC, is that we manage tailings to give certainty in operation, certainty in financial expenditure, and certainty in environmental outcome. So you know the footprint, you know the density, you know the strength, you know the risk. You well understand the risks of what your facility will represent. But there's some, if you like, some unseen benefits that we're starting to realise. And that is, if you look at it in terms of like unexpected opportunities. So if you can manage your tailings to a high density and strength so that you can safely access that, that creates the opportunity to look at, well, maybe you can harvest and reprocess that material again. And we have that with several of our customers where they're now looking at, and I should say customers, particularly with a new operation, where they're kind of learning their process circuit and learning how to improve their extraction efficiencies, etc. When you're first starting, you don't know everything, so the efficiency of extraction is usually quite low. And over time, that improves with knowledge and understanding and process control. So if you could create a system where you could get access to those tailings, those initial tailings once again, there's still value hidden in those tailings. And so using AMC manages the tailings so they are readily accessible and easy to harvest so that you can consider about reprocessing and extracting further value from those tailings, which is an incredible result in terms of sustainability. But it almost becomes, your tailings becomes the gift that keeps on giving. You've extracted some value and now you have yet another potential ore body located not very far from the plant. And the costs associated with the accessing and reprocessing are usually quite low relative to mining a mineral ore body. I guess the other benefit that can be realised from that, and we are exploring this with a particular customer in Brazil right now, is that some tailings only have, water entrained in the processing circuit. So what you're doing is you're taking the ore, you're grinding it up, you're extracting what you want purely through a water beneficiation circuit. And what you're left with is a material which is effectively a slurry, but it's a non-polluting slurry, for want of a better way of putting it. It's just mud. So what we're looking at now is working with our customer, we can actually manage the tailings and we undertake our AMC process and we deliver a high density, high strength material. And rather than just continuing to repeat that process and filling a tailings facility, our customer is now able, because they can safely access the material, they can now harvest that, dig it up, and they can actually put that back into the mine site. So the tailings is now no longer a waste. It's no longer left over. The tailings facility has now become a tailings processing area. So we are part of that staging where we now go and manage the tailings, they dig it up, and they go and return that to the mined out area where they can then commence their revegetation and reconstruct the initial vegetation that was there. And to be part of that process, effectively going full closure on mining, yeah, we're very proud to be a part of that.
Okay, and now for the most exciting part of our podcast today. I understand you're launching a new real-time density sensor. Can you tell us a bit about this innovation, please?
Okay, this is several years, maybe even longer in the making. The real-time density sensor is some rather innovative technology we're about to release to market. This sensor itself has come out of a rather involved and deep collaborative research project with the University of Queensland. And what it does is allows us to measure the density of the tailings remotely. So if you like, we can install this sensor on a machine and beam it down into the tailings, and we can actually measure the tailings density at depth using this sensor. And I guess by being able to do that, not only have the density, from that information, we are also able to infer an undrained shear strength, which gives us a measure of just how strong the tailings are. So by fixing these sensors on the machine as part of what we do for normal operation, this also unlocks another opportunity where we're able to do continuous mapping on density while we operate, and I guess continuous mapping for undrained shear strength as well. And that just will occur as part of what we do in normal operations. And it's hard, I guess, to make something like that sound particularly amazing, but that sort of functionality is not available. It doesn't exist. No one else does this. And if you remember, one of the early questions you asked me with respect to why did you get involved with this sort of technology? Why did you start Phibion? It all came down to the business of being responsible for things that I was uncertain about. What this does is, if you like, answer that question. We are able to provide real-time data, providing that certainty on what tailings density, tailings strength is and will be, and provide that through our existing data acquisition system on our machines, and then make that available on a real-time basis or via the cloud through downloadable files. Again, that sort of availability of data just is not available. And to do it as part of what we do for normal operation, it is a huge leap forward.
Great. And could you tell me a bit about how this sensor will change the way tailings are managed in layman's terms, please?
So conventionally, if you go to any tailings facility, they will measure the tailings at the point of discharge or close to the point of discharge if it's coming through as a slurry. And the next time that occurs is when you can get access or safely get access to the tailings area. And in some cases, you never get safe access. So that means the available data right now is sparse, arguably not meaningful. You're not dealing with anything that's kind of contemporary to any questions that might be asked. So whatever the density was yesterday, whatever it is today, the only thing you know for certain is that it's different. You just don't know how different. But using the real-time density sensor not only solves that problem, but because now we have that information, we can measure that density real time. So with every pass of our machine, we're getting a snapshot of tailings. We're able to identify those trends. We can identify where those trends are working very well. We can identify where things maybe need further improvement. And when we identify areas where there's further improvement, that's an opportunity to change our process to actually deliver an even better solution for the customer. So it gives unique access for a customer into what is going on inside their tailings facility that they currently do not have.
Amazing. And what other innovations are on the horizon for the Mudmaster fleet?
We have an extraordinarily busy research and development program, and it's really quite an incredible scope. So as we know, the world is looking for alternatives to the internal combustion engine. And so we currently use diesel engines on our equipment, on our Mudmasters. So we are examining battery technology, hybrid technology. We're also looking at alternative fuels. Again, that research just continues as the improvements come through, I guess, in the wider world. Of course, as I was mentioning, the implementation and the rollout of the real-time density sensor, I suspect that we don't even know the full potential of this, because the data that we are now going to collect is going to be vast. And so the trick at this point is going to be, well, okay, we have this data. How do we turn that data into knowledge? So right now, we're already getting comfortable with using neural network and AI to help us understand some of the data that we get from our machines right now, to give us a more detailed data analysis capability, but also to give us more of a predictive, or if you like, a learned understanding of what's going on. When we overlap all of the information that comes out of the density sensor and apply that same approach, we can't even predict where that's going to go, but we're expecting very, very great things.
And talking about great things, what's your long-term vision for sustainable mining solutions?
So long term, I would like to see a world where tailings management is seen as a temporary land use. We use the land to manage the tailings, but then we find a way to close this land use and have it available for the next opportunity or next land use. And, that sort of approach, it's good for the environment, it's good for the community, and it's good for society as a whole. And I believe this can be done without compromising the future opportunities. So how we manage the tailings, we can do that without compromising future opportunities on what that land can provide. And our AMC solution and Phibion is really central to that vision.
And how important is your commitment to Australian manufacturing in the evolving mining landscape?
Wow. Look, let's be honest. Phibion would not be here without the long-term support of our Australian manufacturing base. What's the saying? They say it takes a village to raise a child. Well, Phibion's the end product of many suppliers and an enormous amount of hard work. We are forever grateful for their support.
And for our listeners who want to learn more about Phibion and the Mudmaster, where should they go?
Okay, very simply onto the web, phibion.com, Phibion.com.
And just to wrap us up for today, what final thoughts would you like to share about the future of tailings management?
Tailings management is an opportunity. It's also an avoidable legacy. It's not just economic or environmental. How we deal with this, it's a measure of how as a society we are prepared to leave legacies for future generations. Personally, I would hope we can embrace this opportunity and leave a better world filled with opportunity for our children. I see Phibion as an essential part of that journey.
And that wraps up our time with you today. Thank you, David, for sharing these insights into Phibion's work and the fascinating world of tailings management.
Thank you very much for the opportunity to have this conversation. Really appreciate it. And thank you for showing an interest in Phibion.
Thanks so much, David.